next model protocol, timestamp ordering protocol. Okay, so actually one or two times two simple question given in the GATE examination. So that we going to discuss. Okay, that we going very simple logical question is given, conceptual question, theory oriented question. Okay, but by chance if they give one good 2-mark question, you should able to handle that. Okay, so it's not a complex protocols, very simple protocols. Okay, so timestamp ordering. So in this timestamp ordering, we use timestamp values of transactions. Timestamp value of transaction. Each transaction has their own timestamp value. Okay, each transaction has their own timestamp value. Okay, so timestamp value is unique value assigned by DBMS for each transaction in sequence order, you can say. Okay, timestamp is unique value assigned by DBMS for each transaction in one proper sequence order. It means to say in a schedule S, T1 timestamp, T1 enters first if timestamp is 10. Okay, after that if T2 is begins, then timestamp more than previous transaction. After that if T8 is begins, transaction number can be anything. Okay, means T8 begins after T2 beginning. Okay, T2 started execution, after that T8 started execution, then timestamp is 20. Assume after that T3 is begins, then timestamp is 25. Assume that after that some T5 begins, then timestamp is 30, like this. Okay, so T1 begins first, after that T2, timestamp of T2 is more than that, and so on. So timestamp is something, you can simply say that transaction begins time, begins execution time. Whenever transaction begins their execution, the time of execution for which the transaction is started is called timestamp value. Okay, I just written like 10, 15, 20, 25, 30 as an integer. It can be a date and time with respect to milliseconds. Okay, so that we can anyhow, if one transaction started, next second if other transaction started, definitely no two transaction timestamp values are same. Definitely no two transactions can begin at the same time. Okay, there may be at least second or microsecond can be differ. Okay, got it. So the transaction begins time can say timestamp value. Now read the definition. Timestamp value is unique value assigned by DBMS for each transaction in one sequence order. Okay, so transaction with highest timestamp value in the schedule, this is the highest timestamp value. Okay, transaction with highest timestamp value is the youngest transaction in the schedule. This is youngest transaction in the schedule. Clear this? Transaction with minimum timestamp value. Okay, lowest timestamp value is the older schedule. Sorry, older transaction, not schedule, older transaction. Okay, transaction with highest timestamp value is youngest transaction in the schedule, and transaction with minimum timestamp value is the oldest transaction in the schedule. Clear this one? So this is about the timestamp value. Okay, it's a unique value assigned by DBMS for each transaction in one proper sequence order. Clear this? Next. Not only, and there are two benefits of timestamp values. Okay, timestamp value of transaction. TS means timestamp value. Timestamp values of transaction can use as transaction ID. Okay, can use as transaction ID, identification. Okay, we can identify transaction by using the timestamp value of the transaction. Okay, anyhow, it is whenever unique value assigned for all the people, that can be used as ID, identification number. Okay, and second thing, the timestamp value can use to set priorities. Timestamp values can use to set priority between the transaction. Assume you want to give high priority to the older transaction or high priority to the younger transaction, depends on your protocol condition. Okay, you can set the priority by using the timestamp values. Okay, so this is the meaning of timestamp value. Clear this? Next, there is timestamp value for data item. Timestamp value of data items. Data item X. X is one data item. For each data item, there are two timestamp values. One is a read timestamp value of the data item, and other one is write timestamp value of the data item. Write timestamp value of data item. Okay, a read timestamp value of data item is highest transaction timestamp value, that has performed read of A. Read of X, na? We took the data item X, read of X. Highest transaction timestamp value that has done a read of A successfully, okay, is called a read timestamp value of the data item. Same definition for write timestamp value. Okay, highest transaction timestamp value, that has performs write of X. Okay? Okay, let us assume in this schedule transactions are executing concurrently. Okay, transactions are executing concurrently, and these are some set of transactions. Okay, and data, some random timestamp values I am writing, 10, 15, 5, 10, 15, 20, 25 are the timestamp values. Assume these are the timestamp values. So for example, transaction T1 requested read of A, and read of A of transaction T1 is successful. A read of A of transaction T1 is successful. Then a read timestamp value, I just written like RTS, means read timestamp value, and as well as write timestamp value, okay, of the data item. Okay, that each data item, na? So if it is one data item, I directly write RTS of A and WTS of A. By chance, if I take more data item, instead of writing separately, let me format in the table. So for data item A, so the read timestamp value of A is become 5. Okay, clear this? If transaction T1 also writes the A, then write timestamp value of A is 5. Okay, clear this? If transaction T2, okay, transaction T2 reads B, then read timestamp value of data item B, A and this is B. Read timestamp value of data item B is transaction timestamp value of T2, that is 10. Okay, for example, transaction T4 reads the A. What are transaction performs the read? T1 and T4. T1 timestamp 5 and T4 timestamp 20. Highest is 20. Then read timestamp value of A is modified to 20. Okay, clear this? If transaction T3 reads the data item A, transaction T3, listen carefully here. Transaction T3 reads the data item A. See, what are transactions which already done the read of A? T1 done the read, okay, T4 done the read, and T3 done the read. Okay, timestamp value 5, 20, 15. Highest is 20. It is even after T4 read, the transaction T3 done the read. Even though transaction T3 done the read after T4 read operation, but the read timestamp value of A is remains 20. So, among 3 transactions are done read, T1 done the read, timestamp is 5, and T4 done the read, timestamp is 20, and T3 done the read, timestamp is 15. Say highest among all the transactions who done the read operation is 20, it remains 20. So, for example, the transaction T3 done the read B here. Transaction T3 done the read B. Previous timestamp value of B is 10 only. Now T5 done the read, the timestamp value is 15. So read timestamp value of this is become 15. Okay, so clear this? If by chance the transaction T5 writes the B, transaction T5 writes the B, okay, write B of transaction T5, okay, T5 is performs write of B, okay, so write timestamp value of B is become 25. Okay, clear this? Highest transaction timestamp value that has performed read of the data or write of the data. So for data item A, 20 is the transaction who performs, youngest transaction who performs read of A is 20, and for data item B, youngest transaction who performs read B is 15, means this is T3, and for write operation of data item B, youngest transaction who performs the write B is T5, and for data item A, youngest transaction who performs write A is the T1, which is 5. So again repeating same thing, okay, so that you should get the clear idea. So for example, these are the timestamp values. These are timestamp values of transactions T1, T2 and T3 and T4. Okay, timestamp value is 40. Okay, let us take single data item. If more than one data item, A read timestamp, A write timestamp, B read timestamp, B write timestamp. Okay, let us assume one single data item. Okay, then read timestamp value of the data item A and write timestamp value of data item A. One data item only considered. Okay, got it? So now, if transaction T2 requested read of A, then a read timestamp value of A is 20. Okay, transaction T1 reads A. Let's take the transaction T1. Okay, one data item only considered, right? Okay, assume transaction T2 also writes the A. Okay, then write timestamp value of A is also 20. Okay, let's say transaction T4 reads A, then read timestamp value of A is become 40. Okay, after that transaction T3, okay, reads A. After that transaction T3 reads A. See, T2 reads A, timestamp 20, T4 reads A, timestamp 40, and T3 reads A, timestamp 30. So, highest one is 40 only. Even though T3 reads after T4, but read timestamp value of A is remains 40. Okay, and assume that after that transaction T3 writes the data item A. Then previous timestamp value of A for data item A, write timestamp value of A is 20. Now new transaction who performs the write operation T3. So it is higher. So 30 is becomes write timestamp value of A. See, T1 reads, T4 reads, T3 reads. Highest transaction timestamp value who done the read is the T4. Okay, T2 writes, T3 writes. Highest transaction timestamp value who done the write of data item A is the T3. Timestamp value is 30. So why I am discussed separate example. There is a benefit of timestamp value. This timestamp value gives that who is youngest transaction that has done read or that has done write. Okay. So write timestamp value of A is 30. It means youngest transaction who done the write. Youngest transaction, okay, performs write of A is transaction with timestamp value 30. Transaction with timestamp value 30 means T3. T3, this is the transaction, timestamp value is 30. Okay, same as the case for read. By looking timestamp value, I can able to get who is youngest transaction that has done read successfully. Who is youngest transaction that has done read successfully. Okay, so this is, see, read timestamp value of A is 20. Youngest transaction that has done read of A is transaction with timestamp value 20. So transaction with timestamp value 20 is T4. T4 is the youngest transaction among all the transactions who done read of A successfully. Okay, so T4 is the youngest transaction who done read of A successfully. T1 reads, T4 reads, T3 reads. Out of those three, younger one is T4. Okay, so similarly, read timestamp value of A is 40. It means that youngest transaction performs read of A is transaction with timestamp value 40. Transaction with timestamp value 40 means T4. Okay, T4, which is transaction timestamp value is 40. Okay, to know who is younger one done the read of the data item, who is younger one to done the write of the data item, those two can be accessed, those two can be identified by using a read timestamp value of the data as well as write timestamp value of the data. Clear this? Two things we discussed. Transaction timestamp value and data item timestamp value. Transaction timestamp value is unique value for all the transactions assigned by DBMS in one sequence order. Okay, so read timestamp value of data, write timestamp value of data, highest transaction timestamp value that has done read of A, highest transaction timestamp value that has done write of A. By using read timestamp value of A, you can able to know who is youngest transaction who done the read or who is youngest transaction who done the write. Okay. So for example, okay, so assume there is some schedule. Okay, there is some schedule. In this schedule, T is one of the transaction. and many other transactions are there. Assume T is one of the transaction. So I want to know, okay, I want to know, answer this question, just a simple statement, okay. Any transaction younger than T, okay, performs read of A or not. If I want to know this, what condition should test? I want to know, is there any younger one? Okay, T is in the schedule, T is one of the transactions in the schedule, some older transaction than T, some younger transaction than T. Assume these are older transaction, assume these are younger transactions. Okay, so what I want to know younger transaction than T, done the read or not. Is there any younger one? Is there any younger one than the transaction T? Is done read or not? So the T has, okay, if T timestamp is 100, younger transaction timestamp is more than 100. If some other transaction who is younger than T, whose timestamp value is more than T, if done the read, some younger transaction who done the read, then read timestamp value of A is become this maximum value because it's a younger one, and if read timestamp value of A is more than 100, it means younger than the transaction T done the read. Okay, simply we need one condition testing, one comparison. If read timestamp value of the data item, current read timestamp value of the data item is more than transaction timestamp value of T, just think it. Okay, so read timestamp value, assume transaction timestamp value is 100, but read timestamp value of A is more than 100. It means some younger one who is some younger one than transaction T which done the read. Assume some other transaction whose timestamp value is 150 if done the read. Then read timestamp value of A become 150 and transaction timestamp value of T is 100, 150 greater than 100. It means younger than transaction T done the read. Okay, then we can conclude that younger than T, younger than transaction T is done read of A. By chance, this condition falls. This condition falls. Read timestamp value not more than 100. If read timestamp value not more than 100, okay, it means no one who is younger than T, okay, none of this younger transaction performs the read. Okay, so read timestamp value is not more than transaction timestamp value, then what we can conclude that no younger transaction than T, okay, reads A. No one who is younger than transaction T done the read of A. So this is the way we use the read timestamp value and write, same as the case for write. Okay, so read and write timestamp values are meant for to test who is youngest transaction done read, who is youngest transaction done write of this specific data item. Okay, for each data item there are two timestamp values, read timestamp as well as write timestamp. Okay, next, basic idea of timestamp ordering protocol. Basic idea of timestamp ordering protocol. Okay. Basic principle of the timestamp ordering protocol. Okay. See, timestamp ordering protocol allowed to execute transactions concurrently. Concurrent execution is allowed. In between T1, T2 can execute. In between T2, T3 can execute. Like interleaving is allowed. Okay? Timestamp ordering protocols are allowed to execute transactions concurrently. But the concurrent execution of 2 or more than 2 transactions schedule should be equal to serial schedule based on timestamp orders. Okay? It's a little confusing, or what we can say, little more thinking is required. So just listen carefully. Okay? Transactions can execute concurrently. Okay? Concurrent execution of 2 or more than 2 transactions must be equal to serial based on timestamp orders. If concurrent execution of transactions is equal to serial based on timestamp orders, then the schedule allowed to execute by the timestamp ordering protocol. Okay? So it means concurrent execution of transactions must be equal to serial based on timestamp orders. Based on timestamp orders of transactions. Okay? So it means that T1 one transaction, T2 one transaction, T3 one transaction, T1 timestamp 10, T3 timestamp 20, and T2 timestamp 30. Okay, so these are the timestamp values. Assume that 10, 30, 20. It means T1 oldest transaction. After T1, T3 enters. And who is youngest? T2 is youngest. Okay, transaction with maximum timestamp is younger one. Transaction with minimum timestamp, okay, least timestamp value transaction is the older transaction. Okay, what we are trying to say, transactions can execute concurrently. In between T1, T2 can execute. In between T2, T1 can interleave. Or T1 can begin first, T2 can begin first. Anyone can be any position. Okay, interleaving execution, read, write, in between T1, T2 can interleave. In between T2, T3 can interleave. Anything can be done. Okay, in this schedule S. But this concurrent execution of these 2 or more than 2 transactions, concurrent execution of these 2 or more than 2 transactions must be equal to serial based on timestamp orders. Okay, it means the schedule S must be equal to, okay, the schedule S must be equal to serial, what that serial order? Based on timestamp orders. That means T1 timestamp followed by T3 timestamp, which is 20, followed by T2 timestamp. Okay, if this schedule is, this concurrent execution of the 3 transaction schedule is equivalent to this serial based on timestamp orders, then the schedule allowed to execute. Then the schedule allowed to execute by timestamp ordering protocol. By chance, this concurrent execution not equal to serial based on timestamp orders, then not allowed to execute. Okay, so got it. So let me elaborate little more. Assume this is the given schedule. T1, T2, T3 timestamp values are 10, 30, 20. Means this concurrent execution should be equal to serial based on timestamp orders. So what we are expecting? The schedule should be equal to, listen carefully, the schedule should be equal to serial, S dash is the serial, based on timestamp orders. What is timestamp ordering? T1 followed by T3 followed by T2. T1 timestamp 10, T3 timestamp 20, T2 timestamp 30. The schedule should be equal to this serial schedule. Then the schedule is allowed to execute, otherwise not. It means that conflict pair which executed in the schedule, okay? So T1 precede then T3 conflict pair is allowed. Okay, T1 precede then T3 conflict pair is okay. And T3 precede then T2 conflict pair also okay. And T3 precede then T2 conflict pair is also okay. T1 precede then T2 conflict pair is also okay. These kind of conflict pairs, not an issue. These conflict pairs of read and writes allowed. Why we are saying these conflict pairs are not an issue? These conflict pairs not violate equal serial schedule of the timestamp order. Okay, if the schedule consists these kind of conflict pairs, still the schedule equal to the serial. Okay, so now let us see the, assume the T2 requested read of A. Okay, T3 requested read of A. No issue, no conflict pair occur. Okay, because it's a first operation. Okay, it is allowed. Okay, then after that, the T2 is requested for write of A. Before requesting write of A, okay, write of A allowed or not allowed, testing. If you observe, if you allow this conflict pair, then conflict pair precedence is T3 precede then T2. T3 precede then T2 conflict pair is allowed. Even if you allow this operation, still the schedule equal to serial based on timestamp order. So it is allowed. Okay. For example, T1 reads the data item B. No conflict, because read B, this not conflict, this in this not conflict. It is allowed. Okay. Then after that, assume that T3 requested write of B. If we allow, then the conflict pair occurs T1 precede then T3. Okay, T1 precede then T3 conflict pair is also allowed. Even if we allow this write operation, still the schedule equal to the serial. See, interleaving is occur. In between T3, T2 is executed or T1 executed, like this. Interleaving can be executed. Assume after this write B, okay, let's say T2 requested write of B. T2 requested write of B. Okay. Now, if you allow this conflict pair, if you allow this write operation, so T1 precede then T2 conflict pair, T1 precede then T2 conflict pair also allowed, and T3 precede then T2 conflict pair, T3 precede then T2 conflict pair also allowed. Okay, this write operation also no issue. So far, this schedule is still equal to this serial. So these all conflict pairs are allowed. Okay. Now, by chance, the transaction T1 requested read of A. By chance, transaction T1 requested read of A. Now, because of this read request, it become T2 precede then T1 conflict pair. T2 precede then T1 conflict pair. So, assume that this schedule executed in this serial. Assume this schedule executed in this serial. T1 executed before T2. Then this read behaves like initial read for this. But in this schedule, this read is updated read. Okay. So, see, T3 precede then T1 conflict pair. T3 precede then T1 conflict pair, not allowed to execute. So, because of this read, this concurrent execution fails the equal condition to serial based on timestamp order. Because of this read, this concurrent execution not going to be equal to serial based on timestamp order. So, if such a read or write operation is occurs, and first thing, this read request of T1 not allowed because it is violated basic criteria, and the corresponding transaction who violate the criteria is get rollback. Not only, okay, discarded this read means not only read operation is not allowed, it is also get the rollback. Okay, so that is what we again repeating. Okay, one more time. So basic timestamp ordering protocol, concurrent execution must be equal to serial based on timestamp order, and this concurrent execution if equal to the serial based on timestamp order, then no issue. If this concurrent execution not equal to serial based on timestamp order because of either read or write operation, and the corresponding transaction is get rollback. Okay, so timestamp value of T1, T2, T3, 10, 20, 30, 20 means timestamp order is 10, 20, 30, right? T1, T3, T2. Okay, we are expecting the schedule equal to the serial. We are expecting the schedule equal to the serial. So what I mean to say, this concurrent execution should be equal to this serial based on timestamp order. Okay, first read no issue, and this write, the conflict is T3, T2. Okay, T3, T2 conflict not violate equivalent of the serial, then this read B and this write B and this write B. Till this, these conflict pairs are equal to the serial only. Okay, till this, all these conflict pairs are equal to the serial order. Okay, the serial order is not violated. But if you allow this read, then the precedencies become T2 precede then T1. But the serial order not T2 before the T1, T1 before the T2 according to serial order. So this conflict, because of this read request, the schedule fails the equal condition to the serial, and corresponding read is not allowed, and the related transactions get rollbacks. Okay, this is the basic idea of timestamp ordering protocol. Okay, so there are two protocols we are going to discuss here, three protocols. One is basic timestamp ordering protocol, Thomas-Wright timestamp ordering protocol, strict Thomas-Wright timestamp ordering protocol, Okay, so three protocols we are going to discuss. All three protocols, this idea is same. This idea is same for all the protocols of timestamp. So timestamp ordering protocol, if some transaction some schedule successfully executed by timestamp ordering protocol, if some schedule successfully executed by timestamp ordering protocol, it means that that schedule must be equal to, that schedule result must be equal to serial based on timestamp order. Okay, if because of either read request or write request, the schedule is fails equality condition to the serial, the corresponding read or write is not allowed, and the related transaction get rollback. Okay, it is one important point. Okay, so this point is cleared. If this point is cleared, and almost you done 50% of timestamp ordering protocols. Okay, because the goal of every protocol is same. Okay, so when basic timestamp ordering protocol, concurrent execution must be equal to serial based on timestamp order. Concurrent execution allowed, but that concurrent execution of read and write requests, okay, should not violate equal to the serial based on timestamp order. Either because of read request or because of write request, the schedule is fails the equality of the serial, the corresponding read or write is not allowed, and the related transaction get rolled back. Okay, so this is the basic idea of timestamp ordering protocol. Okay, next we are going to discuss a specific protocol, like we going to study basic timestamp ordering protocol, Thomas-Wright timestamp ordering protocol, and strict timestamp ordering protocol. Okay, so those protocols we are going to discuss. This is introduction to timestamp ordering protocol. So far we discussed timestamp order, means a timestamp value of transaction, timestamp value of data item, as well as basic idea of timestamp ordering protocol. And one of the protocol in the basic timestamp, one of the protocol in the part of timestamp ordering is basic timestamp ordering protocol. And idea is same. So let me recollect once so that you will get the idea more better way. So concurrent execution must be equal to, concurrent execution must be equal to serial. Okay. So concurrent execution should be equal to serial based on timestamp orders is the requirement. So this concurrent execution should be equal to the serial. So the protocol conditions as it is, as like the same. For example, T1, T2 timestamp value, and if T1 performs, if the conflict pair assume that T1 performs the read of A and T2 performs the write of A, and still this concurrent execution equal to this, concurrent execution equal to the serial. This kind of conflict pair, no issue. This read is allowed and this write is allowed. Okay. So for example, T2 is requested write of B and then T1 is requested for read of B. And this concurrent, if you allow this read, this concurrent execution not equal to serial based on timestamp. Okay. So based on timestamp, this schedule should be equal to serial T1 followed by T2 equal to this serial. So if you allow this, it is become T2 followed by T1, right? So if such a read or write not allowed, okay. So that means there are some possibility of rollback. Because of read request, there can be some rollback, or because of write request, there can be some rollback. Okay. Let us discuss such a rollback cases. Assume T2 already done the write of A, which is anger. T2 already done the write of A. Anger, timestamp is 20, T1 is 10. After T2 write operation, if T1 requesting read, okay, this should not allow. After T2 write operation, if T1 requesting for read, this should not allow. The reason is, if we allow this concurrent execution not equal to serial based on timestamp order. So this read request is not allowed and this read request of T1 not allowed and rollbacks this transaction. Okay, rollback T1, transaction T1. Okay, similarly, if T2 already done a read of A, if T2 already done read of A, now T1 requesting for write. Okay, anger transaction already done the read. The first read is accepted by the protocol. Anger transaction already done the read because by the time of this read, no conflicts. Anger transaction already done the read. After T2 done the read operation, now T1 requesting for write. If we allow this, the equal serial is not equal to the equivalent schedule. The schedule is not equal to serial based on timestamps. Okay, so the corresponding write is not allowed. This write request of T1 not allowed, and not only allowed for, not only discard this write operation and also rollbacks the transaction. Rollback transaction T1 is the second possible rollback. Okay. For example, one other possibility, if T1 already done the write, if T1 already done the write, okay, by the time of T1 write, there is no conflict occurs, okay, then it is allows, okay. After T1 write who is anger, then after T2 write who is anger transaction, now T1 requesting for write. If you allow this write, the equal serial is not based on timestamp order, okay. If you allow this write, the equal serial T2 before T1, but the timestamp order T1 before T2. So if anger transaction already done the write, the older transaction write request is not allowed. Not only discards this write, also roll back the transaction. Roll. It doesn't mean that conflict pairs are not allowed. Okay, if T1 done, if timestamp value of T1 is 10, timestamp value of T2 is 20, the conflict pair of T1 precede then T2, okay, no issue. But conflict pair of T2 precede then T1 is not allowed. If timestamp T1 10, T2 20, T2 precede then T1, this read request not allowed. T2 precede then T1, this write request not allowed. T2 precede then T1, this write request not allowed. If you observe that, out of these three possible rollbacks, these rollbacks, these two rollbacks, because of write request, because of write request, write of A, okay, and this rollback because of read. Okay, these are the three possible rollbacks in basic timestamp order. If conflict pair precedence and timestamp orders not same, timestamp ordering 10 before 20, conflict pair precedence 20, okay, T2 precede then T1, then such a conflict pairs are not allowed. But if conflict pair precedence, timestamp order is same, then conflict pair is allowed. Okay, so why two rollbacks? Because of write, because read write also conflict, write also conflict. Why only one rollback? Because of read, write read is conflict, but read is not a conflict. Okay, even if T2 done the read operation, okay, even if T2 done read of the data, still T1 can do read of the data. Okay, this schedule is not violated, equal serial based on timestamp values. Okay, so read not going to be cause rollback. That's why one rollback because of read request, two rollbacks because of write request. Same thing we represent in the conditions, protocol conditions. Okay, so first condition, let's say transaction T issues read of A. Transaction T request read of some data item A. Data item A or data item X, anything. Okay. So if some transaction T requesting the read, okay, if some transaction T requesting the read, okay, so what should be the criteria? See, T is one of the schedule. T is one of the schedule. T wants to read the data. Okay, T one of the schedule. T one of the transaction in the schedule. T one of the transaction in the schedule. T wants to read the data. Okay. Now, when we need to see whether allows to read this data or not. Okay, when this read request can be causes failure. Okay, by chance if anger transaction, then T done the write. If anger transaction then T done the write, then this read request is not allowed. Okay, observe carefully. Okay, transaction T issues the read, that we know. So T is the one transaction that is trying to read the data. Okay, now you have to decide, protocol should be decided, okay, that read is allowed or not allowed. Okay, when that read is causes rollback, if some anger transaction, then the transaction T already done the write, then this read request is not allowed. Okay, so how to test that condition? If anger transaction done the write, anger transaction if done the write, it means if write timestamp value of A, greater than transaction timestamp value of T. Okay, assume the T timestamp value is 100. If T timestamp value is 100, this other transaction who is anger done the write operation, then write timestamp value of A this write is already done. The write timestamp value of A is assume more, bigger, assume 150. Younger transaction already done the write. Younger transaction already done the write. Now older transaction T trying to read the data, then this read is not allowed. Okay, then this read is not allowed. If write timestamp value of data is more than transaction timestamp value of T, you can see here also. After this write timestamp value of A is 20. Then T1 is requesting for read. Okay, write timestamp value of A is 20. Transaction timestamp value who is requesting for read is 10. Okay, it means younger transaction already done the write. If younger transaction already done the write, then this transaction T1 read request is not allowed. Okay, so if this is happens, then what we need to do? Roll back transaction T. If this condition true, then we need to do roll back transaction T. Okay. Otherwise, else means what? Write timestamp is not, write timestamp of data not more than transaction timestamp value. If this write timestamp is not more than the 100, if this write timestamp value of A not more than the 100, means younger is not done the write. Younger is not done the write. If younger not done the write, this read is not an issue. Okay? Then else we can say allowed read of A by transaction T and set the read timestamp value. Okay, a read timestamp value of the data is become maximum of current read timestamp value of A with transaction timestamp value of T. Okay, so set the read timestamp value. So if transaction write timestamp value of A more than transaction timestamp value of T, then roll back. And if write timestamp value of A not more than the transaction timestamp value of T, it means younger transaction if not done the write, then read request of T is allowed. Okay, so then allowed to read the data by transaction T, set the read timestamp value. Okay, this is the protocol condition whenever read request is happens. Okay, then second protocol condition, assume transaction T issues write of A. Okay, transaction is requesting for write of A. Okay, same, let us consider the similar scenario. Some transaction T, there are some younger transactions also. Transaction T is there. That this transaction T wants to perform write of A. This transaction T wants to perform write of A. Now, when this write request is allowed, when this write request is causes rollback. So, we already discussed. If younger transaction already done the read, then T write is not allowed. If younger transaction already done the write, T not allowed to write. Okay? If some younger transaction, okay, some younger transaction than transaction T, if already done the read, then this write is not allowed. Okay, how we test that condition? Okay, if read timestamp value, younger transaction, read timestamp value, if read timestamp value of A is greater than transaction timestamp value of T, okay, then roll back. rollback T. Else, one more possibility, rollback. Okay, not only anger is done the read, if anger is done write also. Okay, if anger transaction done write, then the older transaction write also not allowed. Okay, if write timestamp value of A, write timestamp value of A is more than transaction timestamp value of T. If anger transaction already done the write operation, then also rollback T. Then also rollback T. Else, it means no anger than transaction T either reads the data or writes the data. If no anger one either reads the data or writes the data, okay, then allowed to write the data. If anger transaction reads, then this write is not allowed. If anger transaction already writes, this write is not allowed. But if no one anger than T either reads the data or writes the data, then write of this is allowed. Okay, so else what we can say, allowed write of A by transaction T. Allowed write of A by transaction T. Okay, and set write timestamp value of A. Set write timestamp value of A is transaction timestamp value of T. Here we need not require to test the maximum. So the reason is, if anger is done the write, then older write anyhow not allowed. If the write is allowed, the write is allowed means he is the youngest so far who done the write. So no need to test the maximum. Previous for read we need to test maximum, here no need. Okay. So the read request is done. If read request is done, if anger transaction writes the data, this read is not allowed. Okay, roll back the transaction, otherwise allowed. Okay. If write request is done, two possibility of rollback. If anger transaction read, then write is not allowed. First thing, if anger transaction writes, then the older transaction write not allowed. Second possible rollback, if neither anger is reads the data, nor anger is writes the data, allowed to write the transaction. Okay, so this is the protocol condition, but no need to do this much while solving problem. Directly we can see conflict pair precedence. Okay, so let us see the possible question from the timestamp ordering. Consider the following schedule. Which transaction get rollback by using basic timestamp ordering protocol? This is the schedule and these are the timestamp orders. Okay, so instead of applying the protocol condition for read request and write request, so we know that the conflict pairs based on timestamp orders are allowed. Conflict pairs which are so reverse to the precedent timestamp orders are not allowed. Okay, so see here. So these are the timestamp values 10, 30, 20. So 20, 30, 20, 10 is the timestamp value. That means according to this timestamp value, what is equal serial order? Equal serial order, expected serial is T3 timestamp is least 10, followed by T1 timestamp is 20 and followed by T2 timestamp is 30. So this is like 10, okay, T1 times T3 timestamp 10, which is older transaction, then T1 timestamp 20, that is the after T1, after T3, then the T2 timestamp is 30, which is youngest. So conflict pairs in this order is allowed. Conflict pair in this order is allowed. The conflict pair if not in this order, what that conflict pair? T3 precede then T1 allowed. T1 precede then T3. This is T2, right? 30 is T2. Okay, by mistake I written T3, it is T2. Okay, T3 precede then T1 allowed. T1 precede then T2 allowed. T3 precede then T2 is allowed. Okay, if conflict pair not in this order, it is not allowed. Okay, so that's simple to test it. Now T1 one transaction, T2 one transaction. T3 one transaction. Just write the schedule, one by one operation. Okay. During writing the schedule, just see allowed or not. We are expecting this serial order. We are expecting this serial order. Now, T1 requesting read of A is not an issue because it is not makes any conflict so far. Any conflict so far. The T2 requesting read B is also okay. It is these two are not conflict. T3 requesting read C also okay. No conflict so far. Read C, read B not conflict. Read C, read A not conflict. Then T1 requesting read B. Okay, T1 performs read B. Then also requesting for read B is also not conflict with anyone, is allowed. Then no issue so far. Then T2 requesting read C, this one. Okay, so that 1, 2, 3, 4, fifth operation is also not conflict with anyone. Okay, is no issue. Then T3 requesting read D. Okay, is also not makes any conflict. So far no conflict is done. It is allowed. Then the T1 requesting write C. Okay, T1 requesting write C. Okay, so the conflict here, T2 precede than T1 is one conflict. See, T1 precede than T2 allowed, but T2 precede than T1 not in the sequence. Okay, because the T1 the T2 timestamp 30 and T1 timestamp 20. So in this case, T1 precede than T2 okay, but T2 precede than T1 not allowed. Because of this write request, roll back the T1. Okay, so T1 is get roll back, but few more operations are there. Let us see, those are allowed or those are also causes rollback. Okay, then after that, T3 requesting write D operation. Now what the precedence here? Precedence is T3 precede than T2. T3 precede than T2 allowed. 10 precede than 30. T3 precede than T2 is allowed, no issue. Then this is write C. T3 is performs write of C. Write of C is also allowed. Sorry, write of E. Write of E also allowed. It is not conflict with anyone. Okay, so only transaction T1 is performs rollback. Okay, so like this we need to test it. Okay, same schedule, basic timestamp ordering protocol, and let us take the timestamp values or changes. Instead of 20, 10, 20, 30, 10 for T1, T2, T3 timestamp, 30, 20, 10 is the timestamps. Okay, so let us see this. Let me explain one more. Okay, if at all any doubts in previous will get resolved here. Okay, what is expected serial? Write the serial based on timestamp orders. Okay, T3 timestamp, this is T1 timestamp, this is T2 timestamp, this is T3 timestamp. Write transaction based on timestamp values. T3 is minimum timestamp, then T2, then T1 is the timestamp orders, right? Okay, so the timestamp ordering T3 followed by T2 followed by T1. So we are expecting conflict pairs in this order. We are expecting conflict pairs in this order. Okay, let us see any conflict pair is violated this criteria. What are conflict pair allowed? T3 precede then T2 allowed. T3 precede then T1 allowed. T2 precede then T1 allowed. Okay, let me write the schedule. Okay, so T1, T2, T3 are the transactions. T1, T2, T3 are the transactions. See, T1 requesting read, not conflict with anyone. T2 requesting read B, not conflict with anyone. T3 requesting read C, not conflict with any one of the previous operations. T1 requesting read B, also not conflict with any of the previous. And T2 read C, also not conflict with any previous. Then T3 read D, okay, also not conflict with anyone. All these are reads only, not makes any conflict. Then T1 write C. T1 write C. Now there are some conflicts. One conflict, T2 precede than T1. Okay, T2 precede than T1 is allowed. It's same as the timestamp order. Other conflict, T3 precede than T1. T3 precede than T1 also allowed. Okay, both these conflicts, because of this right C, it become two conflicts. Both the conflicts based on timestamp orders. No issue for that right. This right is successfully allowed. Okay, executed. Then after that, W2D, write D. This one, right? Write D. What the conflict because of this write D? T3 precede than T2. T3 precede than T2. See, T3 precede than T2 also allowed. It is also same as timestamp order. T3 precede than T2 allowed. T3 precede than T1 allowed. T2 precede than T1 allowed. Okay? Then after that, W3E. W3E, it is not conflict with anyone, is also allowed. So the conflict pairs which are occurs in the schedule is the serial order only. It means that the schedule is equal to serial. The schedule is equal to the serial based on timestamp orders. Then in that case, there is no rollbacks. No rollbacks in the timestamp order. So all conflict pairs of the schedule is equivalent to the serial order based on timestamp orders. Then you will not get any rollback. Okay? Similarly, we can test for this one. Okay? So according to this schedule, same question. Question is same. Which of the transaction rollbacks using basic timestamp ordering protocol? So expected equal serial. What is the equal serial we expected? T2, T1, T3 is the equal serial schedule. Okay? So these three, T2 precede then T1, T3 are what conflict pairs are allowed? T2 precede then T1 allowed, T1 precede then T3 allowed, T2 precede then T3 allowed. These are allowed conflict pairs. Okay? So let us see the given schedule. T1 requesting read of A, no issue, not conflict with anyone, first operation. T2 requesting read B and read A, not conflict. T3 requesting read C, read B, read A, not conflict. Then T2 requesting read C, which is also not conflict with anyone. Okay, so then R1B is also there, right? So R1A, R2B and R3C is done. Then R1B, fourth operation is R1B. Okay, this is also not conflict with any of the previous. Then fifth operation is read C, is also not conflict with anyone. Then sixth operation, read D, is also not conflict with anyone. Then sixth operation, write A. See, this write A also not conflict because the T2 and T3, there is no write A operation here. Okay, or there is no read A operation here. So this write A not conflict with anyone is no issue. Then T2 is performs write. T2 is performs write A. Because of this write request, these conflict pairs. So one conflict pair, T1 precede then T2. This also T1 precede then T2. T1 precede then T2 conflict pair not allowed. Okay? Because of this write request, the transaction T2 get rollback. Okay? T2 get rollback. But still W3C is there, na? Let us test that one. Okay, WC3. So write C. Anyhow, T2 already rollbacks. No need to test this read. Okay, there is no conflict. So no more rollback. Only rollback of T2. Okay, like this we need to test. So here T1 10, T2 20, T3 30. So what is equal serial schedule? Equal serial schedule. T1 followed by T2 followed by T3. T1, T2, T3 are the equal serial schedule. Okay, let us see the schedule allowed or not. Now these 4 rollbacks, 1, 2, 3, 4, 5, 6, till this no possibility of rollback, okay, because all are reads only. So this R1A not cause rollback, this R2B not cause rollback, this R3C also not cause rollback, then this R2C not causes the rollback, then R3D is also not causes rollback. Till this, and R1B is also there in between, okay, after 4th operation. This R1B is also not causes rollback, then 5th operation R2C not causes rollback, 6th operation R3D. Why not causes rollback? So far no conflicts. Then W1A, no conflict pair now. So this is writes and reads. Okay, this is also okay. Then W2A, the conflict pair is okay, T1 precede than T2. T1 precede than T2 conflict pair. So T1 precede than T2 allowed here. Okay, conflict pair precedence, timestamp orders is same. Okay, no issue for this, write A. Then last operation, write C, W3C. Okay, W3C. Conflict pair is T2 precede than T3. T2 precede than T3 also allowed. This conflict pair precedence and this timestamp orders both are same. Okay, so then what we can say that no rollbacks. What is mean by no rollback? The schedule successfully executed without any rollback means this schedule is equal to serial based on timestamp order. Schedule executed without any rollback. It means the schedule is equal to serial based on timestamp orders. So clear this one. So 4 problems I solved. Okay, so this is the way we test the basic timestamp ordering protocol is allowed to execute by the schedule or not. Okay, so very simple fundamental conclusion of the protocol. Conclusion for this protocol. See, basic timestamp ordering, BTO, let us write it like instead of writing full term, basic timestamp ordering protocol. Basic timestamp ordering protocol. Okay, allowed to execute schedule S. Allowed to execute schedule S. Allowed to execute means no rollbacks. Okay, no rollbacks. If S is conflict serializable, and conflict equals serial order. Okay, conflict equal serial order. Okay, must be based on timestamp ordering. Okay, if conflict equals serial order and timestamp orders is same, okay, conflict equals serial order, timestamp order is same, then such a schedule allowed to execute means no rollback. Basic timestamp ordering protocol allowed to execute the schedule. If schedule is conflict serializable schedule and the conflict equals serial order is same as the timestamp orders. Okay, so it's indirectly, okay, so timestamp ordering of the transactions, timestamp order of the transactions should be equal to one of the topological order. Okay, that is what the meaning of conflict equals serial. Na? Conflict equals serial order means topological order only. Topological order, if it is equal to timestamp order, then schedule guaranteed allowed to execute by the basic timestamp ordering protocol without any rollback. Okay, so means if the schedule is not conflict serializable schedule, then also not allowed to execute. Even conflict serializable but equal serial, not based on timestamp orders, then also not allowed to execute. Not allowed to execute means at least one rollback. Okay? Not allowed to execute means at least one rollback. Okay? So basic timestamp ordering protocol allowed to execute the schedule if the schedule is conflict serializable schedule and conflict equal serial order is based on timestamp order. Okay? See here no rollbacks, na? No rollbacks, right? Okay. If you draw precedence graph, okay, let us see. Then read A, conflict with write A, T1 precede then T2. T1 precede then T2. Then read B, not conflict with anyone, there is no write B. Read C, write C, same transaction, not conflict. And read B, not conflict with anyone. Read C and write C, T2 precede then T3 is the one more conflict pair. And read D, not conflict with anyone. T1 precede then T2 already exists. Assume, see this is the conflict serializable schedule precedence graph. So precedence graph acyclic, schedule is conflict serializable schedule, equal serial schedule, topological order. What is topological order for this one? T1 in degree 0, then T2 in degree 0, then T3. See this topological order, the timestamp order, both are same. Timestamp order T1, T2, T3, topological order T1, T2, T3, such schedules, you will not get any rollbacks. Clear this one? The schedule, basic timestamp ordering protocol allowed to execute the schedule means no rollback. Allowed to execute means no rollback. Not allowed to execute means at least one rollback. Okay? Allowed to execute the schedule means no rollback. If S is conflict serializable schedule and conflict equal serial order must be based on timestamp ordering. It means timestamp order if equal to topological order, then no rollback. If topological order means if the schedule not conflict serializable, if cycle exists, then also at least one rollback. If by chance topological order, timestamp order not same, then also at least one rollback. Okay, got it? So basic timestamp ordering protocol allowed to execute the schedule means no rollback is occurs if the schedule is conflict serializable and conflict equal serial order is based on timestamp orders. Okay, so this is the one protocol for timestamp ordering. The next protocol for timestamp ordering is Thomas-Wright timestamp ordering protocol. We discussed basic timestamp ordering protocol. Next, Thomas-Wright rule timestamp ordering protocol. Okay, there is various similarities. Okay, most of the things of basic timestamp ordering protocol and Thomas-Wright rule timestamp ordering protocol are same. Okay, only one small difference. Okay, so the difference, let me explain difference first, and after that we'll get back to this definition. Let me explain the difference of basic timestamp order and Thomas-Wright rule, and then we'll get back to this definition. So in basic timestamp ordering protocol, okay, if one rollback because of read request, okay, one rollback because of read request, okay, if T2, assume T1 timestamp is 10, T1 timestamp 10, T2 timestamp 20, okay. And if T2 writes the data and T1 a request for read, we discussed this causes rollback. This is one rollback because of read request, okay, in basic timestamp order, and two rollbacks because of write request. T1, T2 transactions, okay, T1 timestamp 10 and T2 timestamp 20. If T2 already done the read, okay, if T1 requesting for write of A, if T1 requesting for write of A, and rollbacks, and one more rollback we discussed for basic timestamp, previous protocol, T1, T2 concurrently executing, and timestamp of T1 10, timestamp of T2 20. If T2 already done the write, then okay, write request of T1 is not allowed. Okay, write request of T1 is not allowed. This T1 is get rollback. Okay, so there are two rollbacks because of write, one rollback because of read. Okay, if younger transaction writes, older transaction not allowed to read is one possible rollback. If younger transaction either reads or writes, older transaction not allowed to write is the two more rollbacks. Okay, in basic timestamp ordering protocol. Whereas Thomas write rule, timestamp ordering protocol. Okay, in Thomas write rule timestamp ordering protocol, same for read request. No difference in the read request. If younger transaction timestamps are 1020, if younger transaction already writes the data, then if older transaction requesting for read and this read request is causes rollback. Okay, this rollback and this rollback both are same. No difference, read request. Okay, if younger transaction already done the write, older transaction read request causes rollback. Same in Thomas write rule. Okay, then one more possibility, T1 and T2. If younger transaction, okay, only done write of the data, not done the read, only write, okay, sorry. If younger transaction already reads the data, younger transaction already reads the data, then older transaction if requesting for write, the second case, younger transaction already reads the data, older transaction requesting for write, and this write request of T1 also rollbacks. Okay, these two rollbacks are same. And the third rollback in the basic timestamp, if younger transaction writes the data, then older transaction write request causes rollback. But the small change in Thomas write rule timestamp ordering, timestamp orders 1020. Okay, assume if younger transaction done only write, not done the read. If younger transaction only done the write, not done the read. Okay, if older transaction if requesting for write. So this causes rollback in basic timestamp order. Whereas Thomas write rule says that no need to roll back the transaction T1, just ignore the write. Okay, ignore the write of A of the T1 and continue the execution. Okay, so clear that if younger transaction only done write. So by chance, if younger transaction done both read and write, if younger transaction done both read A, timestamps are 10 and 20, and write A, then older transaction if requesting for write, okay, then not allowed. Then it is also causes the rollback. Okay, it is comes under this case. Younger transaction already done the read, older transaction requesting for write. In this case, rollback only. Okay, but if younger transaction not done the read, only done the write, then older transaction if requesting for write, instead of rollbacking this T1, ignore the write. Okay, so now see the definition. Thomas write rule, Thomas write timestamp ordering protocol, possible rollbacks. Okay, first rollback, read request because of read. If younger transaction already done the write, then older transaction read request is not allowed even in Thomas write rule timestamp. No change. Okay, so that this is the rollback because of read. Na, just look this one. Transaction T issues read. Transaction T issues read. This is same as this read request, same as basic timestamp. Same as basic timestamp ordering protocol. Okay, if the younger transaction write timestamp value of A is more than transaction timestamp value of T, what it mean? Younger transaction already done the write, then older transaction T requesting for read, then which causes rollback. Same thing. Okay, if anger is not done the write, then older requesting for read, then allowed to read and set the timestamp value. Okay, this is same. Now, if transaction T issues write, okay, if write request one rollback only, if by chance anger is done only read, anger is done read of A, anger already done the read, okay, then older transaction requesting for write, then causes rollback. It means read timestamp value of A if greater than transaction timestamp value of T. It means anger transaction already reads the data, then older transaction T requesting for write, then that causes rollback. This rollback same as basic timestamp ordering. By chance this condition fails. What it mean? What it mean by this condition fail? Anger transaction not done the read. Anger transaction not done the read. Okay. Now second, the else part I written. Else part means the first condition should false, second condition should be true. And second condition is what? Write timestamp value of A greater than transaction timestamp value of T. It means the anger is done the write, then older requesting for write. Anger already done the write, now T is requesting for write. In that case, ignore it. Ignore the write. Okay? So got it. But to ignore this, not only T2, okay, so it's not like T2 is only done the write. Okay, if T2 done read and write, if T2 done read and write, it falls under the first case. Then it is rollback only. If T2 done, if anger is not done read, if only done write, then older requesting for write, then it comes under this case. Okay, this is only the change. Only this case is occurs. Change in the basic timestamp, Thomas Wright rule timestamp order compared to basic timestamp ordering. So previously rollback in basic timestamp order, here ignore the write and continue execution. If neither anger transaction neither reads the data nor writes the data, then allowed to write and set the write timestamp value. Okay, got this one? So read request of Thomas Wright rule, same as basic timestamp ordering protocol condition. Write request of Thomas Wright rule, if anger already done the write, then older trying to write the data, then roll back. If anger not done the read, but only done the write operation, and older requesting for write, then ignore it. Okay. So how, if we ignore, how it is make sure, okay, the schedule is consistent and all, that we will discuss. That we will discuss with example. Okay. So this is the definition of Thomas Wright rule, timestamp ordering protocol. Let us take one question. Assume this is the schedule. Schedule T1 reads A and T2 writes A. Then T1 writes A and T3 is writes A. Let's assume timestamp values of T1, T2, T3. Timestamp values of T1, T2, T3 are 10, 20, 30. 10, 20, 30. Okay, let us take this schedule. If we apply basic timestamp ordering protocol, previous protocol, if we apply basic timestamp ordering protocol, okay, so T1 one transaction, T2 one transaction, T3 is one transaction, T1 is 10 timestamp, T2 20 timestamp, T3 30 timestamp. Okay, so these are the timestamp values. Now T1 read of A is allowed, T2 write of A conflict pair based on timestamp order, 10 precede then 20 conflict pair allowed. Okay, after that T1 requesting for write. In basic timestamp order, if anger transaction already done the write, then older transaction write request is not allowed. Then roll back the T1. Okay, roll back the T1 and after that T3 write no issue. T3 is performs write. Okay, according to basic timestamp order, roll back transaction T1. Roll back the transaction T1. Okay, so this kind of problems we already discussed. I explained 4 problems to test the basic timestamp ordering. Just same way apply for basic timestamp ordering testing. Let us take Thomas Wright rule timestamp ordering protocol. Thomas Wright timestamp ordering protocol. Okay, then these are the timestamp values T1, T2, T3. T1 timestamp 10, T2 timestamp 20, T3 timestamp 30. Okay? And T1 requesting read of A is allowed, no conflict. T2 requesting write of A. Okay, even though T2 requesting write of A, which is conflict, but this conflict is allowed. Okay, the conflict pair precedence timestamp order same. This is not going to be cause any problem in any protocol. Now T1 requesting write of A. T1 requesting write of A. T2 is younger and T1 is older. If T2 already done the write, T1 write request is ignored. Okay, so then what the Thomas Wright rule timestamp ordering says that no need to roll back the transaction, ignore this write. Okay, but continue the execution, no rollback. Okay, after that T3 requesting for write of A, T3 write is allowed. Okay, because T2 precede then T3, same as timestamp order. T1 precede then T3, also same as timestamp order. So just ignore the write, but no rollbacks. So no rollbacks by using Thomas Wright rule timestamp order. So what it mean? What it mean of the ignoring? So what Thomas Wright rule conveys that if you ignore this write, this schedule is view equal to, this schedule is view equal to serial. Okay, view equal to serial based on timestamp orders. View equal to serial schedule based on timestamp orders. Okay, so what is timestamp ordering? T1 10, T2 20, T3 30. Timestamp ordering is T1, T2, T3. Assume these 3 transactions, T1 reading A, writing A, T2 writing A, T3 writing A. T1 operations read A, write A, T2 is write A, and T3 is write A. If you execute in serial order T1, T2, T3 based on timestamp order, all T1 operations read A, write A, followed by all T2 operations write A, followed by all T3 operations write A. Okay, it is simply serial schedule. T1 followed by T2 followed by T3. We know that serial schedule always preserves correctness. Serial schedule always preserves correctness. In first class of transaction concurrency control itself we discussed. Okay, if the transactions execute serially one after other, then result of the schedule is always preserves correctness. Every serial schedule always preserves the correctness. So if you ignore this write, still this schedule which is executed by Thomas Wright rule timestamp ordering is view equal to this schedule. How we will test view equal? Initial read should be same, updated read should be same, final write should be same. So initial read of the given schedule, T1 reading A from initial database. In the serial also, T1 reading A from initial database. Initial reads of S and the serial is same and no updated reads. Final write, according to the schedule S, final write of A is done by T3. According to the serial, final write is done by T3. Okay? So even if I ignore this write, still the result of the schedule view equal to the serial. Okay, so then we can say, even if we ignore, still the result of the schedule is consistent. How we can prove it is consistent? Even if I ignore this write of A, still this result of the schedule view equal to the serial based on the timestamp order. Okay? For that, there is no meaning to roll back the T1. So whereas conflict equals seriality, whereas basic timestamp order makes sure that conflict equal to serial. Okay? That's why every writes is matters. Okay? Whereas Thomas write rule makes sure that view equals serial. Then final writes is matters. Okay? If final write is matter, if younger transaction done already write, older transaction write operation, if we ignore, this result is view equal to serial based on T1 followed by T2 serial. Okay? So what is idea of ignoring this write? Even if I ignore this write, the result of the schedule view equal to this serial. Okay? That is the idea. Okay? Basic timestamp ordering protocol make sure that schedule is conflict equal serial based on timestamp. Okay, Thomas write rule timestamp order make sure that the schedule view equal to the serial based on timestamps. That is a difference. Okay, so let me take one more example. Let's take one more schedule. Assume T1 requesting read of A and T1 also writes the A and T2 writes A, T2 writes B and T1 writes B, and timestamp values, okay, T1 timestamp, 2 transactions only, T1, T2 timestamp 10, 20. Okay, let us see what happened if you go for basic timestamp ordering protocol. Basic timestamp ordering protocol. Okay, so T1 timestamp 10 and T2 timestamp 20. Okay, T1 and T2, T1 timestamp 10 and T2 timestamp 20. T1 requesting read of A, which is allowed. T1 requesting write of A, which is also allowed. Okay. T2 requesting write of A, conflict is occur, but conflict pair and the timestamp order conflict pair precedence is same. Timestamp order also expecting T1 followed by T2. Conflict pair also T1 followed by T2. Then T2 requesting write of B, it is allowed. Okay, now T1 requesting write of B. Okay, according to basic timestamp, if younger is already writes the data, older transaction write request is not allowed. Because of this write of B, T1 get rollback. In basic timestamp order, rollback transaction T1. RB, rollback transaction T1. Okay, let us see what happens if we go for Thomas write rule, timestamp ordering. Okay, so listen carefully. T1 timestamp 10, T2 timestamp 20. Okay, and T1 requesting read of A, which is allowed. T1 requesting write of A, which is allowed. T2 requesting write of A, which is allowed. T1 proceed then T2. T2 requesting write B. Okay, T2 requesting write B, which is also allowed. No conflict for this. Now T1 is requesting W1B. If younger is done, only write B. If younger is done, only write B, then older transaction write request is ignored. If younger transaction performs, only write B. Older transaction write request is ignored. Okay. So what we done over here? Ignore W1B. Okay. Ignore W1B and roll back this transaction. sorry, ignore W1B and continue the execution. Okay, so like T2 writes the data item, okay, only writes the data item. Now T1 requesting for write. In that case, simply ignore W1B and continue the execution. Okay, so clear this one. So now you can ask, if you ignore this write, how you can make sure consistency? For example, if these two transactions are executing, T1 read A, write B, T2 write A, write B. If these two transactions executing serially based on timestamp orders, okay, so serial order, just direct serial schedule. Read A, T1 operation, write A, T1 operation, and write B, T1 operation, and followed by T2 operations, W2A and W2B. Okay, these are T1 operations and these are T2 operations. So clear this one, T1 followed by T2. Okay, so if you observe, even if I ignore this write B, even if I ignore this write B, still this schedule view equal to this serial. This is a direct serial schedule. This is T1 followed by T2 serial schedule. Okay, still this schedule view equal to the serial schedule. View equal to the serial schedule. How to test view equal? In this given schedule, T1 reads A from initial database. Here also T1 reads A from initial database. In this given schedule, final A done by T2, here final A done by T2. If I ignore T1 write, final write done by T2, here also final write done by T2. So initial read is same, final write of A is same, because T1 write is ignored, final write of B is done by same transaction. So still, even if I ignore this write, still result of the schedule view equal to one of the serial. So if that is the case, instead of rollbacking the transaction, just ignore and execute the remaining things. Okay, so this, even if I ignore this write, still this result is view equal to one of the serial. So no rollbacks occur. No rollback in the Thomas write rule, timestamp ordering. Clear this one? So now let us take a small variation, almost similar schedule. Okay, a small variation. So this point you should understand. Okay, assume this is the schedule. T1 read A and T1 writes A and T2 writes A and T2 read B, one extra operation, and then write B. Okay, and T1 is writes the B. And timestamp values of T1, T2 is 1020. Okay, timestamp values of T1, T2 is 10 and 20. Now, if you take basic timestamp ordering protocol, okay, so T1, T2, T1 timestamp 10, T2 timestamp 20. Okay, now see, T1 requesting for read, T1 requesting for write, T2 requesting for write A, which is allowed, T2 requesting for read B, which is allowed, T2 requesting for write B, also allowed. Okay, after that, T2 already done the write B and read B, then, okay, T1 requesting write of B. If anger is already done either read or write, the older transaction write is not allowed. Okay, so this write B is rollbacks. So according to basic timestamp ordering, rollback transaction T1. Okay, let us see what happens in Thomas write timestamp ordering. Okay, let us see what happens in Thomas write timestamp ordering. Okay, so now T1 one transaction, T2 is other transaction. Timestamps are 1020. Okay. Now T1 requesting read of A, which is allowed, no conflict. T1 requesting write of A, which is also granted, and T2 requested write of A. No issue even if it is conflict, because the timestamp order conflict pair precedence is same. T2 requesting read B, which is also allowed. Now T2 requesting write B, which is also allowed. Then T1 requesting write B. Now just think what happened here. Okay, T1 requesting write B. Think what happened. Here, previous example, T2 already writes the B, then T1 write is ignored, not rollbacks. Okay, then continues the execution, we get no rollbacks. But here, if you observe, T2 not only done the read B, not only done the write B, T2 also reads the B. If anger is already done the read, then older transaction write request is not allowed in Thomas write rule also. If anger is already done the read, older transaction write request is not allowed. Okay. In this case also roll back the transaction. In this case also roll back the transaction. Okay. Thomas write rule also roll back the transaction T1. The reason is, even if I ignore this read, the schedule not view equal to serial based on timestamp order. Even if I try to ignore the read, the schedule not view equal to the timestamp order. Okay. So if I write the serial order, okay. So what is a serial order? T1 reads A and T1 writes A and T1 writes B. These are T1 operations. T2 operations, T2 writes A, T2 reads B, and then T2 writes B. Okay, this is T2 operations. T1 followed by T2. Okay, the serial schedule result is correct. But see, let us assume it is not going to be ignored in this case because T2 already done the read. Okay, write request is not allowed, roll back. Assume if it is ignored, then what the problem? Okay, so this initial read same as this initial read. Final write of A same as this final write of A. If we ignore this, final write of B same as final write of B. The problem with this read B, according to this serial, this read B is updated read. According to this serial, according to this T1 followed by T2 serial, this T2 reads T1 updated value. If transactions executed serially, T2 should read the data which is updated by T1. But according to this given schedule, the T2 read B become initial read. Okay, so the schedule not view equal to the serial, not view equal to serial based on timestamp, not view equal to the serial based on timestamp. Okay, the result not view equal to the serial based on timestamp, then the Thomas write rule timestamp ordering is also not allowed. What the difference between this question and previous question? Previous question, T2 done only write B, then T1 write B is ignored. But here, T1 write B not ignored, T1 write B is get rollbacks. Okay, so the reason is T2 not only done the write B, T2 also done the read. If younger transaction done read operation, then older transaction write request is not allowed. Okay, it is same. If basic timestamp order also rollbacks the T1, Thomas write rule timestamp order also rollbacks the T1. Clear this? This is the way the Thomas write rule makes sure, okay, the executed schedule view equal to the serial based on timestamp order. Now, the conclusion for Thomas write rule timestamp ordering. Okay, so we written one statement for basic timestamp ordering conclusion. Let us write one more one point for this. Okay, Thomas write rule, Thomas write timestamp ordering protocol allowed to execute schedule, allowed to execute schedule S, okay, only if result of schedule, view equal to serial, based on timestamp orders, based on timestamp ordering. Okay, so if you remember the similar statement we made for basic timestamp ordering protocol, similar statement we made for basic timestamp ordering protocol. So basic timestamp ordering protocol allow to execute the schedule only if the result of schedule conflict equal to the serial based on timestamp value. Here result of the schedule view equal to the serial based on timestamp order. So basic timestamp ordering protocol close to conflict equal serial order. Okay, Thomas Wright rule timestamp order close to view equal serial order. Okay, so this is the difference between basic timestamp order and Thomas Wright rule timestamp order. Okay, so these are little more complicated conditions. See, if you observe, we didn't use the protocol conditions while solving the problem. So simply we able to solve the problem just by using the read and write sequence. Okay, so I didn't use the read timestamp value greater than transaction timestamp value condition, write timestamp value greater than transaction timestamp value condition while solving the problem. Okay, so just practice these two protocols properly. So there may be a chance of getting one good question from Thomas Wright rule timestamp order or basic timestamp ordering protocol. So far it is not asked this kind of complicated questions. Okay, once in GATE he asked this statement, conflict equals serial order more close to basic timestamp ordering protocol more close to conflict equals serial. Thomas Wright rule timestamp order more close to view equals serial. So this kind of simple theoretical statement used to ask in competitive exam. Okay. So the next one more small modification is the strict timestamp ordering protocol. So that we discuss now. We discussed basic timestamp ordering concept and solves the problem. We discussed Thomas Wright rule timestamp ordering and solves the problems. Okay. So let us see some of the comparison. Either basic timestamp ordering or Thomas Wright timestamp ordering. Either basic timestamp ordering or Thomas Wright timestamp ordering. Any of these protocol. Okay. These protocols guaranteed serializable. Okay. Whereas basic timestamp ordering protocol makes sure that concurrent execution is conflict equal to serial based on timestamp. And Thomas Wright rule timestamp ordering protocol makes sure that view equal to the serial based on timestamp. Either conflict equal to serial based on timestamp or view equal to serial based on timestamp. Both the cases serializability guaranteed. Okay. And one more important thing related to the timestamp ordering protocol. These protocols, timestamp ordering protocols, are always deadlock free protocols. Okay, these are free from deadlocks. Timestamp ordering protocols are deadlock free. Okay, not possible to get the deadlocks if transactions are executing by using timestamp ordering protocol. Okay, so timestamp ordering protocols are deadlock free. The reason is there is no resource holding or waiting for resources. Okay, no concept of resource holding and waiting for resource. Resource means data item. No transaction holding the data. No transaction waiting for the data. If the protocol conditions are satisfied allowed to use the read or allowed to use the write. If protocol conditions are not satisfied, roll back the transaction. Okay, it's something like either do or die. Okay, either allow to execute directly or roll back the transaction. But whereas locking protocol, if you observe, it can hold one data item and wait for other data item. Okay, if so T1 holds one data item, T2 holds other data item, T1 waiting for T2, T2 waiting for T1, then it forms deadlock. Okay, so such scenario not possible here because there is no possibility of cyclic waiting. Okay, no possibility of cyclic waiting. So of course, there is no concept of holding the data and waiting for the data. Okay, if no issue is occur, the conflict pair precedence equal to timestamp order directly allowed to use the read or write. If conflict pair precedence not same as timestamp order, corresponding transaction rollbacks. Okay, so because of no concept of holding, resource holding or waiting for resource, means data item not get holded by anyone, not data item not going to be wait for any transaction. Okay, no transaction wait for data or no transaction is holding the data. So there is no chance to form the deadlock. So this is one important point. Whereas locking protocols, 2PL protocol, strict 2PL protocol, okay, a rigorous 2PL protocol, whereas locking protocols are not free from deadlocks. Okay, deadlocks are possible if we go for locking protocol. Okay, but the timestamp ordering protocols are always free from the deadlocks. If you use the timestamp ordering protocol for concurrency controlling, there is no chance to form any deadlock. Okay, there is no idea of holding data by any transaction or waiting for data for any transaction. Either allow to execute, do it, if not, kill it. Okay, do the execution or kill the transaction. Okay, but no one is allowing for waiting for data. Okay, so got it. Then, but these protocols not free from starvation. Not free from starvation. Starvation may occur. These protocols are not free from starvation. Why it is occurs the starvation? Let us see simple example. T1 timestamp is 10. T2 timestamp is 20. T2 younger than T1. Assume that T2 is younger than T1. Listen carefully. T1 timestamp 10. T2 timestamp 20. T2 younger than the T1. Okay. If T2 writes the data, okay, already writes the data and this write operation is allowed. Now, if T1 requesting for read of A, if T1 requesting for read of A, then a read request of T1 not allowed in both the protocols. Basic timestamp ordering also rollbacks the T1. Thomas write rule timestamp ordering also rollbacks the T1. So T1 get rollback because younger transaction, the transaction T2 whose timestamp value 20, who is younger than the T1, younger transaction already done the write, then older transaction read request is not allowed. Okay, so what we can say, roll back T1 because of T2, because of T2 write operation. Okay, now assume T1 is started again. Okay, T1 is restarted again. Okay, so if it is started again, then it is treated like a new transaction. It is much younger than the T2. So timestamp assigned is 30. Because it is restarts again, okay, timestamp assigned as 30. Now T1 may not roll back because of T2. Now T1 may not roll back because of T2. Because T1 is younger now. T1 get the more priority. Okay, now, but some other T3 is entered into the schedule which is more younger transaction than T1. And when the T3 is started, T3 requested for write. If T3 requested write first, the write request of T3 is allowed because it is youngest write operation. After that, if T1 requesting for read. Okay. This read request again not allowed, not because of T2 write now. So because of T2 write, so if you think about T2 write, T2 proceed then this one, okay, 20 proceed then 30 is allowed. But the problem is T3 done the write operation who is younger transaction. Because T3 younger transaction already done the write, then older transaction T1 write request, read request is not allowed. Again roll back the T1. Again roll back T1. This roll back because of T3. Because of T3 writing. Okay. The same scenario can repeat. Okay. Again assume that T1 is started again with new timestamp value. Then, okay, T4 entered into the schedule, which is more younger transaction. And when T4 is started, T4 requested for write. Okay, then this is youngest transaction, write request allowed in any protocol, then T1 is requesting for read A. Okay, again, because T4 already done, younger transaction already done the write, then older transaction read request is not allowed. And third time also, T1 is get roll back. Again T1 roll back. Okay, so now because of T4. So one time roll back because of T2, one more time same transaction T1 get rollbacks because of T3, same transaction T1 get rollback because of T4. This scenario can happen indefinite time. Okay, so we don't know when T1 can proceed. Okay, then we can say T1 suffering from starvation. Okay, what we can conclude it? T1 suffering from starvation. Okay, so the basic timestamp order, Thomas Wright rule timestamp order, guaranteed serializable, and basic timestamp order, Thomas rule timestamp order, free from the deadlocks, but both the protocols may not free from the starvation. Okay, and next important thing, so these two protocols guaranteed only for serializability, but we also need the strict recoverability. Okay, these protocols, okay, not avoids, not going to be avoid irrecoverable schedules, irrecoverable problem, because strict recoverability not satisfied. Okay, cascading rollbacks, okay, cascade rollback can occur, and these protocols can suffer from last update problem. Okay, irrecoverability not going to be avoided. Okay, cascading rollback problem can occur in both the protocols. Last update problem can occur in both the protocols. Okay, so because only read and write requests are taking care, we are not taking care the commits rollbacks. Okay, for example, just take the schedule. The schedule is like this: T1 requested write of A. Okay, then T2 requested read of A, and T1 requested write A, write B, and T2 requested write B, and T2 committed before T1 is the schedule. Okay, so T1 done write, T2 done read, T1 done write B, T2 done write B, and T2 committed before the T1. Okay, now see, this is uncommitted read, dirty read. Transaction who performs uncommitted read, okay, is committed first. Then this schedule is irrecoverable schedule. Okay, if irrecoverability itself occurs, cascading rollback can occur, last update problem can occur. Write is there na, last update problem can occur. These kind of schedule can possible to execute by timestamp ordering protocols. If I execute by using basic timestamp or Thomas Wright rule timestamp, assume timestamps are 1020. If I execute any of the protocol, basic timestamp ordering or Thomas Wright rule timestamp ordering, any of this protocol. So T1 write of A is allowed and T2 read A is allowed because precedence is T1, T2, same as timestamp order. Okay, T1 write B is allowed, T2 write B is also allowed. We don't bother commit order, any transaction can commit first. Okay, the schedule allowed by basic timestamp, allowed by Thomas Wright rule. Okay, it means it is guaranteed serializable schedule. It is guaranteed serializable schedule, but not recoverable schedule. But not a recoverable schedule. So these protocols are not free from irrecoverability, not free from cascading rollback, and not free from last update problem. These three problems can avoid by using strict recoverability. These three problems can avoid by using strict recoverability. Clear this? So these protocols guaranteed for serializable and these protocol guaranteed for deadlock free, and starvations can occur not free from the starvation, and these protocols not going to be restrict, not going to be avoid irrecoverable issue, cascading rollback issue, last update problem issue. Okay, clear this? Now, to avoid these problem, we need strict recoverable. If strict recoverable incorporated into timestamp ordering protocol, then such a protocol is named as strict timestamp ordering protocol. Third one. Okay, it is a very small thing, only because not much explanation for serializability, only strict recoverability is added. Okay, is the third protocol. Strict timestamp ordering protocol. Okay, strict timestamp ordering protocol says that, okay, must be follow basic timestamp ordering conditions. Basic timestamp ordering, okay, conditions, and strict recoverability should be ensured. Okay, schedule must be strict recoverable. I am just directly writing because the conceptually it is sufficient. Okay, strict recoverable schedule should satisfy. Okay, so we already discussed meaning of strict. If some transaction already done the write operation, if some older transaction already done write, some older transaction already done write, then until commit or rollback, no anger transaction allowed read of A or write of A. If some transaction writes the data, okay, until commit or rollback, no other anger transaction can read the data or write the data. So this is the condition. So one condition of strict recoverability, strict timestamp ordering protocol, basic timestamp ordering protocol, like that the conflict pairs order should be same as timestamp order, and second thing, strict recoverability should satisfy. Okay, so then what the benefit of strict timestamp ordering protocol? Strict timestamp ordering protocol. Strict timestamp ordering protocol guaranteed serializability. Guaranteed serializable. Okay, strict timestamp ordering protocol guaranteed strict recoverable. Okay, no chance to form the irrecoverable cascading rollback last update problem. The strict timestamp ordering protocol also deadlock free protocols. Okay, these are deadlock free protocol, but still starvation can possible. Not free from starvation. So this is about the strict timestamp order. But our goal is these two only, no? So serializability, schedule which is executed should be serializable, schedule which is executed should be strict recoverable. The way strict 2PL is correct protocol. Strict 2PL guaranteed for serializable and guaranteed for strict recoverable. Okay, the way we say strict 2PL correct protocol for concurrency controlling, because guaranteed for serializable and guaranteed for strict recoverable. Similarly, strict timestamp ordering protocol is also correct protocol for concurrency control. Okay, even though minor issues are occurs because of starvation and all, okay, but that is not causes inconsistency. Okay, starvation and deadlock is not causes any incorrect result. Okay, so our main goal serializability guaranteed in strict 2PL and strict recoverability also guaranteed in strict 2PL. Similarly, serializability and strict recoverability guaranteed for strict timestamp ordering protocol. Okay, so concurrency control component can implement by using strict 2PL, or concurrency control component can implement by using strict timestamp ordering protocol. Okay, so this is about the timestamp ordering protocol. So let us see the expressive power set. Okay, assume these are serial schedules. Serial schedules, and two protocols we discussed. One is three protocols. One is basic timestamp order, then second one Thomas Wright rule timestamp order, and third one strict timestamp order. Okay, basic timestamp order, Thomas Wright rule timestamp order, and strict timestamp order. So out of these three, more restricted is strict timestamp order. Strict timestamp ordering protocol schedules. Okay, among basic timestamp order and Thomas Wright rule timestamp order, basic timestamp order, Thomas Wright rule timestamp order. Basic timestamp order has more rollbacks, three possible rollbacks. Thomas Wright rule timestamp order is only two rollbacks. Okay, means the schedule which is allowed by basic timestamp order always allowed by Thomas Wright rule. If no rollbacks because of basic timestamp, that schedule guaranteed no rollback because of Thomas Wright rule. But sometime even basic timestamp order, if some rollback occur, and that schedule may not have any rollback in Thomas Wright rule. And other way we can say basic timestamp order conflict equal to serial based on timestamp. Thomas Wright rule view equal to serial based on timestamp. We know view equal serial based on timestamp more expressive than conflict equal serial based on timestamp. Okay, so out of these two, more expressive is Thomas Wright rule. Thomas Wright timestamp ordering protocol. Timestamp ordering protocol schedules. Means schedules which are allowed by Thomas Wright rule timestamp order. This one is basic timestamp ordering protocol. Basic timestamp ordering protocol schedules. Okay, clear this one? Serial schedule always subset strict timestamp. It means that every schedule which is allowed by basic timestamp ordering protocol, every schedule which is allowed by basic timestamp ordering protocol always allowed by Thomas Wright rule. But schedule which is allowed by Thomas Wright rule timestamp ordering protocol may not allowed by the basic. So Thomas Wright rule timestamp order, more expressive power. So this is all about timestamp ordering protocol. So we discussed locking protocols as well as we discussed Thomas Wright rule protocol. Okay. So first we started with acid properties, then conflict serializability testing and view serializability testing we done, then recoverability testing we done, okay, and locking protocols we did, and timestamp ordering protocols we did done. Okay. So almost all model questions also covered. Okay. So one or two other model questions are there that we are going to discuss during the explanation of workbook. Okay. So before start discussing workbook, please solve each and every question from the workbook. Okay. So previously also I told you, before start practicing workbook or before taking video lecture of the workbook, you should try each and every workbook question once. Okay. So without your attempt of the workbook questions, if you simply see the solution, it means you lose the meaning of question. Okay. If you didn't thought anything about the question, you didn't try how to solve the question and what may be the answer and all, okay, without trying from your side, if you simply see the solution, then you did nothing for that question. That kind of preparation never helps you for competitive exam. A new question is there, you have to try first. Okay, then only you need, if you try, then you get it, then okay. If you not get it, at least you will came to know what wrong you done. Okay, without any thinking of the question or without any solving of the question, if you simply see the solution, okay, that is completely wrong preparation. That kind of preparation never helps you for competitive exams. Okay, even for test series, some people what they do, simply they click and submit the paper. Their target is what? They should get the paper. Okay, they will download the PDF file of the test series and then they see solution and compare it. Okay, solution and understand. Okay, that is always wrong. Even if some questions wrong, okay, those questions you should try first. Okay, you should try first and then you need to see the solution. Anyhow, solutions are there. We are providing solutions. Okay, either workbook solution or test series solution or previous gate solution. Solutions are there with you. Okay, so but you should not look the solution directly without sincere attempt from your side to solve the problem. Okay, so this is all about transaction and concurrency control. The next thing we are going to discuss workbook discussion. Okay, so workbook I will explain in such a way that already similar model question is covered and I will just display the solution and tell the answer. If new model question is there, I will explain in detail. Okay, so thank you so much. Then next we will meet for workbook discussion.